So this is going to be a multi-part set of videos dealing with an important type of equation in math, and it's called a proportion. Of course, the plural form would be proportions. All right, and the good news is they're pretty easy to solve once we see a shortcut, but they lead to a very broad set of application problems that we'll also talk to in subsequent videos. Okay, and so what a proportion is, it's just an equation of the form where you have a fraction equal to another fraction. Okay, like that. And so just some basic examples here would just be x over 3 is equal to 4 over 5, something like that. And they could get a little bit more complicated. I could have something like x plus 1 over 7 is equal to x minus 2 over 4. Now, on one other common type that might not look like a proportion at first, but I could have x plus 4, x over 4 is equal to 6. Okay, well here it doesn't look like we have a fraction equal to a fraction, but remember a whole number we can always write as a fraction over 1. Okay, so the key thing to recognize about a proportion is that you have just a single fraction equal to a single fraction. Same thing here. Make sure you realize this, we just don't know what this numerator is, but this is one single fraction, just a numerator and a denominator, equal to just a numerator, just a denominator. And same thing here once we rewrite it. Okay, now why am I keep emphasizing this? So you might get a little bit confused with equations that we've been dealing with that have fractions in them. So we've seen an example like x over 3 plus 1 is equal to 3/4, something like that. Okay, and so make sure you realize over here on the left side, this isn't a single fraction. It's a fraction plus something else, okay? And so this is not a proportion. And the reason that it's important to distinguish is there's going to end up being a shortcut to solving these. Now, if you might be prone to forget that or not keep up, then we can always solve these the same way. So we can always solve any equation that has fractions by clearing the denominators, just as we've been doing. So you can always do them that way, but with a proportion specifically, there's actually one step that we can, or a couple steps that we can skip and get right to the answer. So let's look at this first example that we did a minute ago and do it the way we normally would by clearing the fractions, and then we can see the shortcut. All right, and so we find our common denominator. Our common denominator is the product of the two denominators, so 3 times 5 is 15. All right, and so I want my new denominators to be 15. All right, and so I need to convert each one of those fractions to have a denominator of 15. So I start with the x over 3. What do I multiply top and bottom by so that my denominator ends up becoming 15? All right, and so I'd multiply top and bottom by 5. So I have x times 5. Just remember I can rewrite that as 5x. All right, and then I come over here to this 4/5. What do I multiply its top and bottom by so that the denominator becomes 15? I would multiply top and bottom by 3. All right, and so I end up with 4 times 3, which is 12. All right, so notice that all the denominators are the same, and so I can cross that out, and I get 5x is equal to 12. Okay, now I'm going to come over here because I want us to see the shortcut, but then you would divide by 5. You would end up with x is 12 over 5, or 2 2/5. All right, but let's look at what happened here whenever we got to our solving. All right, that if you look carefully here, we ended up with 5x on the left, and we ended up with 12 on the right. And just remember where that 12 came from. It was 4 times 3. So now let's look back at our original proportion here. Here's an x, and here's a 5, and it ended up over here on the left, right? And then remember that 12 came about as 4 times 3. And see, here's the 4 and the 3 in the original equation, all right? And so what kind of shortcut can we notice here is essentially all I did was multiply these two things together, and then I set them equal to these two things multiplied together, okay? And those colored parts are called the cross products. All right, and so there's a shortcut for proportions that you can take advantage of. Like I say, if you might be prone to forget that this only applies to a proportion, i.e. where you have a fraction equal to a fraction, you can just always go through, anytime you have a fraction, you can go through this process. It'll get you to the same place. But with proportions, what we say is that we can equate the cross products. All right, and so that's the way we'll solve proportions. Now, so we want to use this phrase that we're going to equate cross products. Okay, one phrase that I want you to try to get away from is students will often say that we cross multiply. Okay, and I caution you against using that. Okay, and I'll show you why. This just happened in the past. I have people that will cross multiply, so they'll say 5x and then 4 times 3 is 12. Okay, but they forget that we're solving an equation, and so they won't write the equal sign there because we're just saying to cross multiply. There's nothing about an equality in that statement. All right, and so then they'll end up thinking that we're simplifying something. They'll just do 5 times 12 and write 60x as their answer. You got to remember what we're doing. We're solving an equation. We're trying to find x, and all we have is some expression here. So I highly discourage you from using that terminology to cross multiply. Try to get this terminology down here that we equate the cross products. So we find the cross products, but then we set them equal to each other. So that's the reason I use that terminology. Okay, so let's see if we can do this. So here's three proportions that we can try to solve. As always, I encourage you to pause and see if you have that down, even from that brief explanation. But I'm going to go ahead and carry on here. All right, so looking at our first one here, we have x over 7 is equal to 3 over 5. Now make sure you got to realize that, especially by the time you take a test or something like that, this is a specialized technique for proportions. So remember what that means. That means that we have a fraction equal to a fraction. Okay, so we can only use the shortcut whenever we have that special case. And so notice in all three of these, a fraction equal a fraction, a fraction equal a fraction, a fraction equal a fraction. So these are all proportions, but be careful of that. And also in the deeper picture about in life, whenever you can use this. But since we are solving proportions, we can equate the cross products. And so the idea here is that here's my first cross product right here, and then right here is my second cross product. Okay, and so for my first cross product, I have x times 5, and so that would be 5x. Remember, we can always rewrite x times 5 as 5x. All right, and then over on the right side, I have 3 times 7. 3 times 7 is equal to 21. And you can see now once we get to this step, it's a pretty easy equation to solve. I just need to isolate my variable x, so I would divide by 5. I'm going to come over here to leave myself some room. But we have x is equal to 21 over 5. And if you want to cover your bases, then also give the mixed form, I would encourage doing that. Okay, and we should be checking this. I'm just saving some time in the video, and we've talked about how to check. Just remember, if you're going to put a fraction into a fraction, make sure to use parentheses in that numerator. So if you're going to check that left side, you're going to plug in 21 over 5 in for x right here. And so on your calculator, you would type in 21 over 5 in parentheses, and then divided by or over 7 to get that decimal. And then that should come out to be 0.6. If you type in 3 over 5 on your calculator, you'll also get 0.6. So it does check. Okay, so let's move on to this next one. This one looks a little bit trickier because our variable is in a denominator, but it's still the same idea. We have a fraction equal to a fraction, and so we can equate the cross products. My first cross product is right here, all right, and my second cross product is right here, all right, and so to get my equation, I just do 4 times y, that would be 4y, equals 9 times 5, that's 45, all right? And then, so this is a pretty straightforward equation to solve now. We divide by 4 on both sides, and so we get, and again, in your work, I would keep going down. I'm just saving myself some room on my screen, okay? And so we get x is 45 over 4, and then if you converted that to mixed form, it would be 11 and 1/4. Okay, like that. And again, you should check that. One thing too to point out about all of these, even this one, once we get to the answer, we should answer in fractional form. Okay, we don't want to convert these numbers to decimals. Why is that? It's because our equation came in fractional form as well. Okay, now the third one's a little bit trickier. Okay, I'm going to see if I can do something here. Yep. Okay, and so give us a little bit more room. Now, see, you got to identify your cross products here, and see that entire numerator is part of the first cross product. Okay, like that, and then our second cross product is pretty straightforward, 4 times 3. But the key thing to realize here is that for my first cross product, the one in red, I'm multiplying these two things together. That means 5 is being multiplied by the entire thing, c plus 2. So I want to use parentheses there whenever I write the product, okay? And then on the right side, we just have 4 times 3, which is 12, okay? And so those parentheses will remind you that you need to distribute that. That's a very common error for people to make in this kind of problem, all right? And so here we have 5c plus 5 times 2 is 10 is equal to 12, okay? Like that. And then, so now we have a straightforward equation to solve. And so I'd want to subtract 10 on both sides to isolate the c. So we get 5c is equal to 2. And then I would divide both sides by 5 to get c by itself. And so I get c is equal to 2/5. All right. And again, we should check that. Now this one's interesting to point out how to check it. Let's talk about that. Okay. All right. So first of all, anytime you plug a fraction into a fraction, you're going to need parentheses, okay? But also anytime you have an operation in a part of a fraction, you're going to need parentheses. We discussed that in our review videos, okay? And so if I'm going to check this, for my left side, I'm going to type in 2, let me write that, type it like it'll look on your calculator. 2 over 5, that's my answer, that's my C, and then plus 2, and then I would hit divided by 4. Okay, and if you go and do that, you'll end up, and if you hit enter, you're going to see that you get 0.6. Okay, like that. And then if you, for your left side, the left side is just 3 divided by 5. If you type that in on your calculator, you also get 0.6. That's interesting that they check to the same number in problems 1 and 3. And just to point that out back on problem 2, I realized that now if you type in 4/9 on your calculator, it's going to give you 0.444. It's going to give you a bunch of 4s, okay, like that. Now to plug the right side in on your calculator, you'll type in 5 divided by, but our answer is a fraction, so we want to put it in parentheses, and then you would type in 45 divided by 4, like that. And so you go and plug that in. It's going to give you that 0.44, etc. Also, so this one also checks. Okay, we're going to look at 3 more examples, and I'm going to try something with my video program to hopefully eliminate running out of room every time. Okay, so these are 3 more problems, numbers 4, 5, and 6. And so, again, as always, feel free to pause and try it out. Okay, so let's look at problem number 4 here, though. All right, and so again, we have a proportion. We have a fraction equal to a fraction. So first thing we want to do is isolate our cross products. There's the first one, and there's the second one. Okay, like that. And the key thing to realize, just like with that last example, is on my first cross product, I'm going to be multiplying 3 by this entire thing. So I need to make sure and use parentheses. Okay, I'm going to go to the right. You might want to keep going down. Okay, but we have 3 parentheses x plus 1 is equal to 2 parentheses x minus 1. Okay, like that. And now the only thing that's different in this problem is that I have 2 parentheses that I need to distribute out. Okay, so on my left side I would distribute that 3. So I have 3x plus 3 is equal to, and then on my right side I have 2x minus 2. So again, as always, make sure whenever you're distributing, remember to distribute over the entire parentheses. The most common error people make is they will get the 3x, but then they'll forget here and write plus 1. Okay, so anyway, though, we're ready to solve now. I'm going to move my variables to the left side. So I'd subtract 2x from both sides. Like that. 3x minus 2x is 1x, but remember we can write 1x as just x, and then plus 3 is equal to negative 2. Okay, and then just to isolate x now, I would subtract 3 from both sides. And so I have x is equal to negative 2 minus 3 is minus 5. Okay, now you got to be a little bit careful about checking on this one. Whenever you check this one, notice that numerator and denominator both have operations in them. So that means if you're going to plug in that left side, you need parentheses for both the top and the bottom. And so my x is negative 5, so that top would be negative 5 plus 1, and then I'd say divided by negative 5 minus 1. Be careful too. Remember your calculator's picky about negative and subtraction. So these are negatives, but that's actually a subtraction. Okay? If you go and plug that in on your calculator, it's going to give you, it's going to say 0.66. There's going to be a lot of sixes, and then it's going to round off that last digit. This is actually called an infinite decimal. The decimal actually goes on forever. It's just a bunch of sixes after the decimal point. Okay? And then if you go and plug in if you plug in your right side, that's 2/3. Or so you'd type in 2 divided by 3. You're going to see that same number come up. So that means that this checks. Okay. So remember to circle answers. All right. So now let's look at problem number 5. Okay. Oops, sorry. Didn't mean to do that. So this is similar to the last problem, and it's just a little bit more complicated, and hopefully you notice I'm just building up complication at a time. But here's my first cross product. Here's my second cross product. Okay, like that. And so to get started, I just equate the cross products. So I have 5 parentheses 2x plus 3 is equal to 3 parentheses 4x minus 1. Okay, and then I need to distribute. First on the left, I distribute the 5. So I have 10x plus 15. And then over on my right, I need to distribute the 3. Okay, and so we have 12x minus 3. All right, so now this is a good example. So I told you in earlier videos that if you want to, you can always move the variables over to the left. But some people look first to see, and remember we can move variables to the right. You might want to ask yourself why I would say it's advantageous to move them to the right here. And it just requires a little bit of forethought and some arithmetic in your head, so don't feel like you have to do this. But see, my first step would be to subtract 12x right here. So I'd have minus 12x. That's going to give me a negative in front of the variable. Some people don't like that, and some people don't mind. I actually don't mind. And the reason I don't mind is I know how to deal with negatives, and I don't make very many silly errors when I do that. But a lot of people would move the variables over to the right-hand side to avoid that. And so I'm going to do that in this example. You don't have to do this, by the way. If you always move variables to the left, I would advise you to pause right now and go through the work and see if you get the same answer you should. Okay, so anyway, so then over on the left side, these are going to zero out. So all I have left on the left side is 15, plus 15. But remember, if something begins with a plus, we usually don't write it. And then we have 12x minus 10x, that's 2x, like that. And then we have this minus 3. Now, since I committed my variables over on the right side, that means I have to move the numbers over on the left side. And so here I have this minus 3. The opposite operation would be adding 3, like that. So I have 18 is equal to 2x, like that. And then lastly, I want to isolate my variable. And so I'm going to write it over here to save myself some room for the next. And so we get x is equal to 9. Okay, now for checking again, if you're going to plug in that 9 to check, just make sure to use parentheses around your numerator, use parentheses around your denominator, and both of those, and then that should give you 0.6 whenever you do that. And then if you plug in 3 divided by 5 on your calculator, you'll also get 0.6. Okay, so let's see, number 6. So let's move on to number 6 here. And so for number 6, oops, that line moved with me. I'm just going to rewrite it then. Okay, so for number 6, we have 2x minus 1 over x plus 4 is equal to 2. Now you got to be careful on this one because this isn't technically, it's not written as a proportion, okay? And so to have a proportion, we need to have a fraction equal to a fraction. And so how can I fix that? I can think about that 2 as being 2 over 1, all right? Like that. And then now, it's a little hard to diagram it in there, but there's my first cross product. And then here is my second cross product. All right, so that's the first thing about this. And there's a couple things in this example. So if either side of your equation is a whole number, you want to write it over 1 to get it in fractional form. Okay, the other thing, something strange is going to happen if, hopefully it didn't stump you if you paused and tried it. But on my left side, I'm going to have 1 times 2x minus 1 is equal to 2 times x plus 4. Okay, like that. You can think about distributing the 1 if you want to on the left side, but also remember 1 times anything is just itself. And so however you do it, this left side will just be 2x minus 1. Okay, over on my right side, I have 2x plus 8. Okay, so I start trying to move my variables over to the left side, and remember in these cases, just go normally, but just try not to get yourself stumped. Let the math present itself. What's the problem here? We have 2x minus 2x. That's 0, so that part goes away. All right, so over on my left, all I have is negative 1, and then over on my right, I have equals 8. Okay, like that. And see, so again, remember we talked about this in the last video. Here my variables dropped out, and what else do I need to look at? This statement is not true. Negative 1 does not equal 8, and so we got an untrue statement. So do you remember what that means? That means that there's no solution to this equation. Okay, and so and that, you know, this is a good practical example. These kind of problems later on, depending on how far you go in math, these end up tying into some geometric ideas whenever we do what's called graphing. And often we have to set up these kind of equations to see if certain phenomena occur, and it very often that doesn't occur, and so we end up seeing that by trying to solve this equation and seeing there's no solution. So that idea of no solution or infinitely many or all real number solutions, it does show up more often than you might think. Okay, so I'm going to leave that there. This is just the basics on how to solve proportions. And like I mentioned before, they actually end up solving a lot of very practical problems out there in the world. And so that's what the next couple of videos are going to go over. All right, I hope that helps. All the best.